Okay, so in the last class we have discussed regarding the turbochargers. Okay, turbochargers, we were in the intercooler charger. Okay, at the half we have discussed regarding the intercooler chargers. Sorry, intercoolers used in the charger. Let us see, I will share some slides for you. Okay. Mm. Okay, now this is what the intercooler which is used in the turbocharger, and you can see the function of the intercooler in the red mark. You can see over here there are the hot gases which are entering. These are the hot gases which are enters in this intercooler, and over here these hot gases are being converted into cool gases, and they are coming out by the another side, that is an exhaust side, into an cool. Okay, the temperature is reduced of that hot gases, and the gases are being cooled and introduced into the engine. This is what the main function of the intercooler, just to reduce the temperature of the air which is coming from the which is coming from the exhaust of the turbine. Okay, which you have studied in the previous classes, turbochargers, where the turbine is being used, from where the hot gases is coming out, that is been intercooled, which has been intercooled in the intercooler, which has the temperature has been reduced, and it has been exhaust to the introduced into the engine in by cooling its temperature. Okay, this is what the main function and the importance of this intercooler. What is the importance of this intercooler? Why the intercooler is used? Okay, so first of all, the intercooler, the main function of the intercooler is to reduce the temperature. Okay, if the temperature of the gases which enters, you can see, which enters in this cylinder, that is a piston or the engine, you can say, if the temperature of these gases are been reduced, so the density of the gas will be more. If the gas density of the gas will be more in the SI engine, the maximum quantity of the fuel can be burned. Okay, this is the first point. If you compare to the diesel engine, the combustion is occurred due to the compression of the air. Okay, if the density is more, the compression percentage of the air will be more, by which the fuel also burn more. Okay, if the fuel is burning more, then the detonation and the knocking will be reduced. For that reason the intercooler is being used. Okay, without intercooler, what will happen? You can see in this diagram, the temperature will be increased and the density of the air will be decreased. Once the temperature increases of the air, okay, the fuel may burn before its burning time. Okay, the fuel burns before its burning time. At that moment, what happens? The detonation and the knocking may starts in the engine. So this is a very important role of an intercooler which plays in the turbocharger or the superchargers. Now you can see the simple construction how the intercooler works. So see, this is an intake chamber in which the air is being inserted. This is an, okay, from where the air is being inserted, due to which there are the some aluminiums or the coppers tube. So see, the construction of the intercooler is just similar like an radiator. Okay, you have seen the radiator in the car. The car radiator is used for the cooling of an engine. Same way the intercooler is, the construction is also same, which works like an cooling system. Okay, from one side you can see the intake chamber is there, from where the air is being inserted into the intercooler, from where there are the small copper tubes are being used. Okay, these copper tubes having a thermal fins are there. You can see the zigzag fins are there. These thermal fins are exposed to the atmosphere. Okay, what does this fins do? The fins absorb the temperature from the air, okay, which passes from this to absorb the temperature and releases to the atmosphere. Once the temperature or the heat is been absorbed from the gas, okay, it is been released into the atmosphere, automatically the gas starts to cool down, or the temperature of that gas has been reduced out. This is how the simple construction of the intercooler is there. From the other side, the cooled gases get exhausted and enters to the compressor. This is what the simple construction of the intercooler is there. Now let us see the working of the intercooler. How does the intercooler works? So see over here there is an air. Now you can see over here there is an air filter is there, from where it comes to the turbines. From the turbines over here there is a compressor is there, or the crystal is there. Okay, over here both from the air filter it comes to the compressor, from the compressor it comes to the turbine, from where, sorry, not from the compressor, from the air filter it comes to the compressor. From this compressor the high pressure air with a high temperature enters to the intercooler. From this intercooler, okay, the temperature of the air is been reduced, the air is been cooled down, okay, but at the same pressure it is transferred to the engine. In this engine the combustion occurs by the help of the air or the air fuel mixture. Okay, then afterwards the whatever the exhaust gas is there, or the exhaust air is there, which is coming out from this engine, then once again coming off this engine enters to the turbine, from this turbine, okay, the catalytic converter means what, any of the impurities or something is coming out by the gas, carbon contents are being collected in the catalytic converter, and the remaining gas is been thrown out, and the whatever the particles are there are been collected over here. So this is what the simple working of the intercooler, which is work in the superchargers and the turbochargers. Now once again I will tell you, from the air filter it comes to the compressor, from the compressor intercooler, from the intercooler the temperature of the air is being cooled, and the cooled gases are being intact in the engine. It works in the engine, okay, whatever the gases are there coming out by the exhaust, okay, after completion the exhaust gas is coming off that engine, okay, from this engine it transferred to the turbine, from the turbine it's come out through the catalytics. Okay, with the help of this exhaust gases the turbine moves, by the help of that turbine the compressor moves. Okay, this is what the simple working of the supercharger and turbocharger with intercooler. Okay, now you can see this is also the same diagram. Filter is there, this is a compressor is there, from where the gas is entering into the intercooler, where the temperature is reduced and it is transferred to the engine. When there is an exhaust stroke is there, from this exhaust strokes the gas comes to the turbine, from this turbine allows the turbines to move, and whatever the extra exhaust gas is there, that is transferred to the catalytic converter. With the help of this turbine the compressor has been rotates. So like this way the supercharger and the turbocharger works. If the compressor is only used without the turbine, it is called as a supercharger. If the turbine is being used for running the compressor, it is called as a turbocharger. Keep in your mind, and this is the intercooler which is being used. So this is what the simple diagram. Okay, just I want to share you that what about the intercooler. So this is what the intercooler works. Now let us go for the, hello, hello.
Hello, sir.
Are you there? Hi, no?
Hi, sir.
Okay, okay. Now let us go with the turbo. Now we'll see the turbocharger legs. Now you see the turbocharger lag. What do you mean by the turbocharger lag? This is the time period required for the exhaust gases to accelerate the turbine and compress. It is represented a short delay period before the boost pressure increases. So see, when the exhaust gases are coming out from the engines, okay, that exhaust gases goes to the turbine, dashes to the turbine blades and makes the turbine to rotate. Okay, with the help of that turbine, if the turbine rotates, the shaft is connected to the turbine and the compressor in between both the compressor and turbine. Turbines rotate, the shaft also rotates, that shaft rotates, the compressor also rotates. Okay, so this is what the cycle is been worked in the supercharger and turbocharger. When there is a delay in the exhaust gas, compressor is rotating, supplying the same pressure in the same constant pressure, but the exhaust gas which is coming from the engine takes some time to rotate the turbine. Okay, that time of the delay of the coming gas from the engine makes the turbine to rotates in a lesser time means what, it takes some delay time, that time is called as an turbocharger lag. Do you understand? That is called as a turbocharger lag. Okay, so this is how the turbocharger lagging is done, and this is what the turbocharger lag is there. Okay, the limitations of the turbocharging. What are the limitations of the turbocharging? Now you can see over here, the turbochargers needs a special exhaust manifold. Special exhaust needs and special exhaust manifolds means what? A special exhaust wall is required so that the gas can come out and rotates the turbine. Now the larger pumping elements of a nozzles are required. Larger, just mute your mic, please. Just mute your mic, Shraj, it is disturbing me. A larger pumping elements or nozzles are required to inject more fuel per unit time. This overloads cams and other components. So see what happens if there is an camp is there. Camp means what? The piston movement is done by the means of the camp is the reciprocating movements of the piston is done by the camp or the crankshaft. We can also call it as a crankshaft. A larger pumping elements of the nozzle elements or the nozzles are required to inject the fuel. So the fuel should inject in faster way so that the maximum or the timing or whatever the stroke timing is there of the piston should complete in a faster way. There should be not ignition delay should be occur. If there is an ignition delay, what happens? The exhaust gas to which is coming out from the exhaust wall, that will also take the delay and which makes the turbocharger lag. Okay, this is one of the important limitations of the turbochargers. The turbine blades efficiency is very sensitive to the gas velocity. Okay, the turbine blades which are being used, hello, if anybody having the doubt, then only unmute the mic, otherwise please unmute the mic. Please mute the mic. Sorry, please mute the mic. Mute the mic, please. Khalifa. Okay. Now it is difficult to maintain the satisfactory air charging over the complete operating range of the engine. So it is also one type of challenging. Okay, the special types of designs has to be made of that engine for to make over the turbocharging, lagging, knocking. Okay, this all the things are been to be understood. Okay, for it is also and some of the thing for difficult thing for making an over complete range of the engine. So slightly you can control it, but you cannot overcome these things. Okay, now let us see the difference between the turbocharger and mechanical supercharger. The turbocharger, first, the energy of the exhaust gas is used to run the supercharger. The mechanical supercharger, the mechanical energy is a prime mover to run the supercharger. So see, whatever the exhaust gas is coming, that is used to run the turbines. So that is why it is called as an turbocharger. And over here the mechanical energy means what? The single compressor which is not connected to the turbine, it is been rotate or revolved by the means of belt drive pulleys or the gear which are directly connected to the engine load, that is the crankshaft. Okay, it needs a waste gate control. It does not require a waste gate control. So see, waste gate control means what? Where the exhaust gas are coming out. Okay, over there is some control valves has been used. The excess exhaust gas can be disappeared to the atmosphere. Okay, it and in the mechanical supercharger there is no use of the exhaust gas, so for that reason no waste gate control is been used over there. Okay, it requires a specific exhaust manifold. It does not require a specific exhaust manifold because the exhaust gas is not used in the supercharger. It is directly connected to the engine. So there is no use of the exhaust gas been done in the supercharger. But in the turbocharger, the exhaust gas is been used for running of the turbine. For that purpose, the manipulated is been used. In CI engine, it reduce a smoke. Okay, in CI engine it reduces the knocking tendency. So see, the CI engines are nothing but the combustion ignition engines, that are the diesel engines which produce the maximum smoke. Okay, which produce the maximum smoke because the maximum air is been compressed in that one. The CI engines maximum works on the air compressions. Okay, in the air compression, so the maximum air is been used. With the help of that maximum exhaust air which is going in the atmosphere by the means of silencer, the engine exhaust gases are been coming out, that are been used for the rotation of the turbine, for making the turbine movement. By this the smoke is been reduced over there. Okay, then afterwards it goes in the crystal. Whatever the dirt particles are coming, hazardous gases have been collected, and the fresh, or not the fresh but less some amount of the toxic gas have been released out in the turbocharger. But in the mechanical charger, the CI engine, it reduces the knocking tendency. Knocking tendency means what? The knocking occurs before the ignitions, the spark is being generated, that is been reduced by supplying the fresh air and the maximum air in the CI engines. So these are the some of the differences of the turbocharger and the superchargers just now we have discussed so far. Now over here just I have covered your maximum 50% syllabus of your fourth module. Okay, in the fourth module there are some. Now we'll go with the other part of your fourth module, that is an fuel supply system for SI engine. I will share that also you for you. Just mute your mic please, who is sitting on the front of TV.
Sir, it's disturbance, sir.
Who is someone has 1 minute, 1 minute. Hello, please mute your mic. Who is that one? Please mute your mic. Mute your mic, please. Khalifa. Is it okay now? Google Drive. Scan. Okay, students, I will share directly the camera for you all. Okay, off the textbook. Now see over here. Now you can see the conventional fuel is there. Okay, in your syllabus, the half portion of the syllabus is that supply the fuel system supply for the SI engine in the conventional fuels, alternate fuels, alternate fuels, normal and abnormal combustion, then the cetane number, octane number. We are going to study what are the octane numbers, cetane numbers, fuel mixture requirement for the SI engines, types of carburetors, okay, CDSS carburetors, multi point and single point fuel injector system, and fuel transfer pumps, fuel filters, fuel injectors, pump and the injectors, electronic injection system, and common rail direct injection system. So these are some of the concepts. Okay, the half portion of your module number 4 that we are going to study is in the next classes. Now the half portion I have completed over here, that is in module number 4. Okay, you can see over here the supercharger and turbocharger, the natural aspirate engines, force inductions, types of superchargers we have studied, turbochargers we have studied, construction and operations of the turbochargers, and the intercoolers and the inter turbocharger lags. Okay, this we have studied now. So over here the module number 4, your half portion is completed, and the remaining half portion we are going to discuss in the next classes. Okay, that are the fuel and the fuel supply system for the SI engine. Okay, in that the conversion fuels we are going to study now. Now you can see over here the conventional fuel system. What do you mean by the conventional fuel system? The conventional fuel system is what? Nowadays whatever the fuels which are conventionally obtained or by the natural source fuels are obtained, on which the automobiles are been running or the engines are been working. So which are the common fuels you are using now? One is on petrol, another one is on diesel, and next one is on gas, that may be in the LPG gas or the CNG gas, liquid petroleum gas, or the carbon monoxide gas. So these are the some of the combustion fuels which are using, that are also called as conventional fuels. The basic requirement of the fuels, the basic requirements, sorry why the file was not opened, I don't know. Just I will next class I will prepare that properly in a PDF form and we'll go with that file. Just you by the camera I will try to explain you what are the concepts are there. Okay, in the next class we'll go with that one. The conventional fuels.
Sir,
Oh, what happened?
it's it, it's not recording, sir. Recording is sir.
Huh?
Recorded, sir. It is not recorded, sir.
You are recording that one?
Not recording, sir. Video.
You cannot, you can't see in the screen.
Uh, see, sir. Recording not is there, sir.
ಏನಾಗೈತೆ?
Recording video, sir. Recording video ಆಗವಲ್ದು ಸರ್. ಈಗ ಆಮೇಲೆ ಬೇಕಂದ್ರೆ ಸರ್ ಇದು ನೋಡ್ರಿ ಸರ್.
ನಾ ಕಳಿಸ್ತಾನಲ್ಲ ಇದನ್ನು ಇಮೇಜ್ ಕಳಿಸ್ತಾನೆ ನನ್ನ ಕಾಳಜಿ ಮಾಡಬೇಡ.
ಹಾಂ ಹಾಂ
ನೀ ರೆಕಾರ್ಡ್ ಆಗ್ತಿತ್ತೆ ನಿಂತ್ರಾಗ?
ಇಲ್ಲ ಸರ್, ಆಗದಿಲ್ಲ ಸರ್. ಅದಕ್ಕೆ
ಇಲ್ಲಿ ನೀ ಮಾಡ್ತಿದ್ದೆ
ಸರ್ ರೆಕಾರ್ಡ್.
ಅದಲ್ಲ, ಬೇರೆ ಲೆಕ್ಚರ್ ರೆಕಾರ್ಡ್ ಮಾಡಿದ್ದೆ ನಿನ್ನ ಒಳಗೆ? ನೀ ಮಾಡಿದ್ದೆ?
ಹಾಂ ಸರ್, ಬೇರೆ ಸರ್ ಎಲ್ಲ ಸರ್ಸ್ ಮಾಡ್ತಾರೆ ಸರ್ ರೆಕಾರ್ಡ್ ಸರ್.
ಹಾಂ,
ಅವರು ಮಾಡ್ತಾರೆ ಸರ್, ಇಲ್ಲಿ ಆಗವಲ್ದು ಸರ್ ಅದಕ್ಕೆ.
ಇಲ್ಲ ನಾವು ಮಾಡ್ತೀವಿ ಬಿಡ, ನೀವು ಮಾಡ್ತೀರನ? ಹಾಸ್ಟ್ಗೆ ಅಷ್ಟು ಅಲೌಡ್ ಐತೆ ಅದು ರೆಕಾರ್ಡಿಂಗ್ ಮಾಡಕ್ಕಂದ್ರೆ ಅಷ್ಟ ಆಗ್ತೈತಿ. ಅದಕ್ಕೆ ಹೇಳ, ಹೋಸ್ಟ್ ಅಷ್ಟ ರೆಕಾರ್ಡಿಂಗ್ ಆಪ್ಷನ್ ಬರ್ತೈತಿ. ನಿಮ್ತ್ರಾಗೂ ಬರ್ತೈತಿ ರೆಕಾರ್ಡಿಂಗ್ ಆಪ್ಷನ್?
ಇಲ್ಲ ಸರ್, ಬರಾತಿಲ್ಲ ಸರ್ ಅದು.
ಬರತ್ತಿಲ್ಲಲ್ಲ? ಆಯ್ತು ಆಯ್ತು, ಕಾನ್ಸೆಪ್ಟ್ ಕ್ಲಿಯರ್ ಮಾಡ್ಕೊರಿ. ಇದ್ರ ಇಮೇಜಸ್ನ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ದು ಇಮೇಜಸ್ ಕಳಿಸ್ತಾನು. ಅದು ಪಿ ಡಿ ಎಫ್ನಾಗಿದ್ರೆ ಅಷ್ಟು ಓಪನ್ ಆಗ್ತಿತ್ತು. ಅದು ಪಿ ಡಿ ಎಫ್ ಯಾಕೆ ಕನ್ವರ್ಟ್ ಆಗಿ ಲ್ಯಾಂಬಲ್ಲ, ಅದು ಓಪನ್ ಆಗುವತ್ತಾಗಿತ್ತು. ಅದು ಅದ್ರ ಸಂಬಂಧ. ಹಾಂ,
ಓಕೆ ಸರ್.
okay, I will send you, don't worry, no problem. Okay, otherwise we next class also will repeat the same topic if you are having any doubt. Okay, so the conventional fuels are there. So the basic requirements of the fuel used for the internal combustion engines are, okay, that is the IC engines. The combustion must be complete within the minimum possible time to release the maximum amount of the heat energy. So this is what the basic requirement. The combustion in the CI engine should be done in a less time, okay, as soon as possible it to be done, so that maximum heat can be heat energy can be released, due to which the fuel can burn in a maximum quantity. Okay, so this is what the conventional engine requirement is there. The in the conventional fuel requirement is there in the internal combustion engine. Okay, the requirement mentioned above must be fulfilled for a longer time. A longer portional operational result in the form of the deposition and many sites affected, such as wear and tear and appears. So see, if the fuel is not in an proper requirement, okay, the requirement mentions above must be fulfilled for a longer time. The longer oh, okay, so last 10 minutes we are having. Okay, in 10 minutes we will discuss. So today's class was not so much proper. So I will take one more extra class. Okay, I will decide on send you the link. The requirement mentioned above must be fulfilled for a longer time. The longer portion results in the formation of the deposition, and many sites efforts such as wear and tear may occur. So see that the fuel should be in such a manner that it should avoid the detonation and the knocking within the engine during the compression stroke. If the knocking and the detonation is not avoidable or been resist, the wear and tear may be occurs. Wear and tear means what? The piston's size may be increased due to the generation of an more heat, due to which it can't rough to the cylinder, which by which the wear and tear may occurs, and also the pistons may be go under some cracks. Okay, now if we go for the fuel as in petrol, if you use the petrol is an internal combustion engine, that is a must sorry okay, in SI engine, the fuel used in an internal combustion engine must possess the certain physical and chemical composition combustion properties, such as it should have the high density, good combustion quality, high thermal stability, no tendency of deposit formation, low toxic, free from the pollution, and the product of the combustion should not be harmful, etc. So high energy tendency means what? It should high energy tendency means what? It should have the energy level should be more, so that it can generate the heat energy. Over here the heat energy is a high energy tendency. Okay, it should require the density is often high energies, that is an heat energy. Okay, in internal combustion engine. And the good combustion qualities means what? Whatever the fuel is been sprayed, whatever the fuel is been sprayed. Hello, can you hear? Can you hear?
Yes, sir. Yes,
Okay,
sir.
okay. The good combustion quality means what? Whatever the fuel is being sprayed in the combustion engine, okay, that should burn out completely during the compression stroke. High thermal stability means what? The stability means what? Whatever the temperature is increased within the engine, it should have the stable format. Okay, it should not increase or excess due to the generation of the heat or the detonation. Okay, no tendency of the deposition formation means what? The carbons which is released by the burning of the fuel should not deposit on the walls or the head of the pistons. So this is one of the important properties that the fuel should require during the using. Now if you go for the gasolines means what? The gas fuels which are being used for the engines. Okay, and a gasoline has to satisfy the following requirement. Which are the requirement that fuel should be satisfied in the conventional food? It must be free from the knocking tendency. Okay, it should be free from the pre-ignition tendency. Pre-ignition tendency means what? The if the ignition is occur before the pistons moves to TDC from the bottom dead center to from bottom dead center to top dead center. Okay, at when the piston reaches to the top dead center, the engine should spark or the ignition should be occur, so that with the pressure of the spark and the ignition, the piston comes from the top dead to bottom dead. Okay, once the piston, before reaching the piston to the TDC, the ignition is occur, that is called as an pre-ignitions. Okay, that may goes for the knocking and the detonations of the engine in the cylinder. Okay, engine in the cylinder, so that should be avoided. It should be free from the free ignition engine. It should burn, the fuel should burn exactly at the time when it has to be burned, when the engines comes to the BDC to TDC. It should not decrease the volumetric efficiency of the engine. What do you mean by the volumetric efficiency of the engine? Does not decrease the volumetric efficiency. The volumetric efficiency is nothing but the volume, the from the bottom dead to top dead, whatever the area is there in the cylinder, that is called as a volume. The engine should cover the total volume, that is a swept volume from the bottom dead to top dead. That complete length or the area is should be the, it should, the piston should have the movement between that complete area. If the piston doesn't moves in that complete area, so that it is called as a less efficient piston, less volumetric efficiency engine. So the volume within the engine is not been utilized by the piston which it has to be utilized, so it is called as a less efficiency volumetric efficiency of the engine. It must be able a very everywhere and must be cheap also. It must be available, sorry, it must be available everywhere and must be cheap also. So see the gasoline, now you can see the CNG, you can have the LPG, CNG petrol, sorry, not CNG, petrol and the diesel petrol pump everywhere in the cities, or you can see anywhere. Okay, but you cannot get the LPG and the CNG pumps which okay, for the supply of the, for the automobile vehicles, there are rare. Okay, for that reason the you can get the LPG in everywhere in the home, but you cannot get the CNG in the home or anywhere. If the LPG gas is been used for running the engine, it can be you can get the gases everywhere, but you are using an CNG, it is difficult to get that for the your bikes, or sorry, not for the bike, for the cars also. Okay, so this is also one of the important thing, that it must be able available everywhere and must be cheap also. It must have high calorific value. What do you mean by the high calorific value? Fuel burning value is called as a calorific value. Whatever the gas is been introduced in the engine, okay, in the cylinder, it should burn in the maximum number. It should not form in gums or vanish. The gums or means what, by due to that gas, the some of the dirt particles or something should not happens on the engine. Meeting is over. Hello, can you hear? Hello.
Yes, sir.
Okay. Okay, now we'll go for the diesel now. Can you see this screen? Okay, sorry for your
Uh,
disturbance today. Today the class I was not satisfied with this class, so I will discuss in the next class same topic. Okay, because I have not why the I don't know why that slides are not converted in the PDF. If it is in a PDF form, then only it can be shared in the screen, then you can visible on your screen. So that is why I'm using the back camera for the textbook to explain you all. Okay, if you take the diesel
yes.
fuel, okay, last topic I will cover this one. The diesel fuels are the petroleum fractions that are lies between the kerosene and the lubricating oils. The crudes source and the refining method influence the fuel properties. Okay, so see the diesels just lies between the kerosene and the lubricant. Okay, the lubricating oil is there, whatever the engine oil is there, it lies between the kerosene and that one. Okay, diesel fuel. So what does the desirable characteristics of the diesel fuels are? The cleanliness, it should be free from the carbon reduce. Okay, the carbon should not, have you said you have, if you have seen the diesel cars or the bus trucks, okay, which works on the which engines runs on the diesel, they are releasing more carbon dioxide, more smokes. Okay, so the diesel fuel should not release such a more fuels and the carbons. Okay, after burning by the when it comes as an exhaust gas and other contaminants. Okay, ignition quality, the cetane number and the diesel index, API gravity. So the see the cetane number, so we are going to study in this module the cetane number and the octane numbers of the fuels. That is, an cetane number is used for the diesel and octane number is used for the petrol, but it also works in the SI engine and CI engine. What do you mean by the cetane and the SI number? We are going to discuss in details in this module only. In the next concept we'll go. Okay, the ignition quality in the cetane number is nothing but the combustion quality, combustion or the fuel grade, you can tell as a diesel grade. The grade is been given 60, 70, 80, the cetane number, that is a diesel grade is been given. On that number the combustion of the fuel is been depend. Okay.